All right, I'm here in Seattle and we are at Kafatek. I'm here with Dennis. It's such an honor to be here. What we're gonna do right now is we're gonna do a bit of a tour of your shop, because this is one of the last few places that makes grinders in the United States, right? You're manufacturing, you're doing it in-house.
Everything.
And I want to show that off because this is just super cool to be able to come to a space. You know, you go to your coffee roastery, you see coffee getting roasted, you see production spaces. This is like that, but for an actual product, right? For a coffee grinder, there's so much that goes into it, and I really want to show that off because it's just super cool. So we'll have Dennis here to take us away and show us into his shop and around. We're gonna end up at a cool little showroom, but there's just so much that happens here. And you guys already know it, Monoliths is my favorite grinder, so that's why we show up and we're gonna show off the Monolith, right? How's it made and all that.
All right.
All right.
So, as we enter, we have our assembly room. Hey guys, this is Brian.
Hey.
It's a Jonathan. That's a Victor. We are a small team. We have 4 people. So Jonathan and Victor, they do the assembly. So this is the latest batch of the conicals.
Yeah, wow.
Getting ready to go out.
Yeah, maybe somebody watching their grinder is gonna be in this
definitely,
batch. Yeah.
Definitely. So these ones are awaiting testing. Once we finish the assembly, every single one gets tested. So before we do that, nothing ships.
Yeah, a lot of testing. You know, so we're starting off with the manufacturing stuff, and then we're gonna go inside.
So on the manufacturing side, this is a surface grinder. So pretty much for all the flat burrs, you have to grind them super flat and parallel. And we are talking about a couple of microns flatness and parallelness. So that's the machine that does that. We grind about maybe, I don't know, 16 burrs at a time.
Yeah, because you're also making the burrs in-house. That's
Yes,
one thing. So we'll see that there as well.
Yep.
But very rare to be making burrs in-house.
Yes, indeed. And like Mike, this is Brian.
Nice to meet you.
Mike is my manufacturing guy. He pretty much runs everything in the shop. So this is like super critical machine for us. And this is a Zeiss CMM machine. So pretty much what this allows us is to measure every single part and get a very precise measurement of features on it. So in this case, we are making the burr blanks and we are measuring the blanks to make sure they are in tolerance. The way we want it, like the outside diameter, the inner diameter, stuff like that. So this is like the simple measurement, but for example, maybe we can bring a body. This gives us a view into the parts and we measure 100%. Like every single part that goes in a grinder that touches the burr, we measure it.
Wow.
So this is like basically something we pull out of the box, and there is a QR code on the bottom that we put in, and that connects to the report that is in the system.
So you pull up everything that has been measured?
Yes.
Okay.
So we would pull that in. I would grab our program.
Oh, there it is.
So that's a body, and then body, we're gonna run that. It's gonna ask for a number. Boom. So what this does, this scans the top surface of the body because we want to know the flatness. And this scan will pull out about 2,000 points. So as it's scanning, it's measuring the height and the flatness. So we want to know how flat this body is, because that's one of the critical features. And it's scanning on the outside because that's where the variation will be the largest. The farther you go from the center, you know, any problems get magnified on the edges. which is why the smaller burr is much easier to make flat than the larger
I
98
see.
burr. So it's the same for like the grinder or the components that go into the grinder. And then we're gonna measure the burr chamber diameter. So this is also pulling like 1,000 points. So it's gonna measure the bearing diameter. Yeah, so pretty much all the features that we care about. And then it generates the report with a go, no go. Pass, does it pass? You know,
So you check all the parts.
every
okay.
single one.
Wow.
That's why there is a QR code on it. And then when we put them together, like in this stage, we put the burr carrier in, that gets measured as well
I see.
to make sure it went together correctly.
Yeah. Very tight tolerances.
Yes.
Right.
So we'll see what this one is.
All green.
So all green. So we have the flatness of the body, that's a 9 microns. That's extremely tight. We have another critical dimension is perpendicularity, like how square the bearing is to the top face. That's at 1 micron. That's
Wow.
crazy. So pretty much we try to keep everything under 10.
Okay.
We want 10 microns or less on flatness, parallelness, or squareness. So it's gotta be really, really flat square. And the interesting thing with this is if you go into the flatness, you can plot all these points.
Oh, wow.
So this, I think, magnification is 5,000 to 1. So this is like the plot of the whole thing.
And you do this for every single part.
Every single part.
Wow.
So we want to know what it is. And if there is any issue in manufacturing, we're going to be able to see it. And especially if we magnify it 5,000 times, we can see, okay, you know, there is a problem there, we need to look into that. So this has been a really critical machine to get. Like you can do all the measurements manually, but the problem is usually there is no record of it, and you will not get a 2,000 point scan. So this is extremely valuable machine. Really, really the key.
Yeah. So you could tell if somebody messed up your grinder, right? They send you pull up the records. Like, oh,
Yes.
no, it's perfect. What are you dropped it on the floor or something.
Yeah.
Yeah.
Almost like that. And then here we have the automated cell. So this one uses a universal robot. The robot just goes and picks up the parts from the rack, puts them in the machine. Each of these pallets has got the RFID tag. The robot comes in, reads the tag, knows what to tell machine to make. The machine makes it, and pretty much we can run this 24/7.
Fully automated.
Fully automated. And this is a 5-axis machine. On this machine, we make everything round. So right now we are making a burr blanks. So this is the burr blank
Yep.
that
Before,
we make. And the whole process of the burr making starts with this. It's a solid piece of metal. Then we heat treat it to make it hard. So we have that over there. The next is we would make the blank. The blanks, this one is ground. So that's coming from the surface grinder. So that would be, like you can see, this surface is ground. So right now this is really flat and parallel. And the next step is to add the grinding teeth.
And then,
So after that is done, we send it out and we get a coating on top.
wow. Okay, so there's a life of the burr right there.
That's pretty much the life of the burr.
Wow. And then you use the arms for everything.
And then,
too.
yeah, so this machine, the robot will go in, put a one part, get a blank out. And, you know, it does that all day long.
Yeah. And you wrote the code for that?
Yes.
Wow.
So pretty much all the parts I have designed, all the parts I have programmed on the machines.
Wow.
So
incredible.
it's everything in-house. And then on the other side,
So now we're in the other room
yes,
here.
on the other side we have
Another.
another robot, automated. So this machine makes the bases for the grinder. It can make the bodies too, burr carriers, stuff like that.
And it all starts with like a block of.
It all starts
Yeah,
like a block
wow.
of metal. So pretty much this is the raw material everything starts from.
Wow. So you take this. Wow. Very heavy.
It's heavy, yep,
And
that
then you
goes
turn it into
mounted
parts. Yeah.
on these pallets. This uses a custom code that I wrote. It's got the custom server for a pallet management. So in this case, you can see we have 30 pallets, and then you can simply tap and select, I want to run
Oh,
this,
I see.
and then it just does it.
Yeah. So it's all mapped to this, and then
Yeah.
and then it does everything there.
Yep.
Wow.
And now it's gonna pull out this.
Oh, look at that. Here,
So right now it's running a drying cycle to get the coolant off. Yeah, so that's a conical or a flat base top part. And now machine signals to the robot, I'm done. And then the robot will come in and pick that up.
That is so cool. Wow. Look at that.
It's a number one.
Wow.
Yeah.
That is so cool.
So machine is doing the cleanup cycle, washes everything down because of the chip.
Oh yeah, yeah. So it cleans it up, and then it's gonna go and find another part and do
Yep.
it all over.
Yep.
Wow. That is super cool.
Yeah, this is where the fun is.
Yeah. So you just let it run 24/7 basically.
If we can.
Yeah.
And sometimes it's way too hot during the day to run,
Oh, okay.
and then we run overnight.
All right, so it's gonna find the next part.
Yep. There you go.
Picks it up. So this is another base.
Another base.
Sticks it in.
Yeah, so that's the probe. That's a kind of a safety feature, or the verification, if you will. It's going to make sure that what the program expects is what is inside of the machine. So it's going to just check the size, basically.
Checks
Yeah,
the
it's a
back.
G code with the macros. And it's happy with that, and it moves on and makes a part.
Oh, change it to the drill bit.
Yep, changes to the end mill, and
It's
and
all
that
automated.
goes all day long like that.
Yeah, wow, that's super cool.
And on this machine, currently, this machine works a little bit different. So this robot actually picks up the raw material and puts it in the machine. So right now we are making max bodies. So this is also automated, as you can see here. The raw material is up on a rack. The robot goes in, picks it up, puts it in the machine, and takes the part out, and it's done.
See the life cycle of the grinder already.
Yes. And then on this machine, this is probably, I would say, the most complex machine in the shop. We make right now the lower burr carriers for a max. So we start with pretty much a chunk of metal like this. And this comes out.
Wow.
So these are the lower burr carriers.
How long does it take to get that from there?
It's
About an hour.
about an hour.
Okay.
Yep.
We stop it in the program at certain stages so that we can measure tolerances.
I see.
And then, like, if it's a little over, we restart it from the spot after, like, cutting a little deeper, and just get to the precise measurement. Every single one.
Wow.
Yes. Like the key, because this is a highly critical part, the burr carrier, we want to measure every single one because it doesn't make sense to make a bad part. If you get to the point where you measure them on a Zeiss and you see the bad parts, then you are throwing the parts away.
I see.
You want to catch them at this stage and don't make a bad part.
And then the Zeiss machine there is just for final checkup.
Yes.
I see.
But like, you don't want to get there with the bad parts. It means they were not checked here. So that's why we like, this is runs super slow. And we also make conical burrs on this machine,
Yeah.
the shurikens.
Tons and tons of parts laying around everywhere, raw materials everywhere. It's super cool.
Yeah.
Where does all the excess metal go?
It goes into the bins.
Dropping down into that bin.
Oh, okay,
Conveyor
right here.
belt.
So there's all the excess steel bits.
Yes. And then it gets into the bins up front and it gets recycled.
Wow.
Yeah, you can see it drop it. Let's cover some super secret stuff.
Super secret.
There you go.
There's nothing here. Don't
There's
worry
nothing here.
about it.
No, nothing. Not in at all.
But there's something that is
New.
also secret. Well, maybe secret for now.
Yes. So all the Maxes that we will ship in a September batch. So if you have a Max order in September, it's going to have the blind burrs.
I'm trying to figure out how to react to this. So yeah, this is amazing. This is so cool. You're gonna be able to get a flat Max with a blind burr.
Yes,
in it.
and you're going to be able to mount any
Yeah.
other burr in it if you wish.
Yeah. So on the Flat Maxes, Flat Max 2, because you got the pre-breaker up top with the pancake burr,
Yes.
that acts as a pre-breaker. So what you can do is you can make these blind.
Indeed.
Right, and then you get more.
And there are
surface
no
area.
pre-breakers.
Yeah. But right here, oh, these are just so cool. I mean, the thing is if you've ever had a chance to hold a Kafatek burr in your hands, it feels so good. I know that, and not that many people open up their grinders to take the burrs out and play
Yeah.
around with them a lot. Especially, you get the monolith, and you just kind of just let it be. Don't touch it, don't mess with it. But if you ever get a chance to open it up and you hold the burrs, it just feels so good. I want to quickly. Can you go over this design real quick, if you want to share?
Yes.
How these are done.
Pretty much I started this design the first one I made was 2021.
Wow. Okay.
And the first design I used the magnets.
You tried to put it on the back.
Like everyone uses the magnets, you put the magnets on. And I kind of, during the testing, I didn't like that because I was worried they're gonna slip off, maybe vibrate on the hard beans when you grind them. And I wanted to solve it a little bit better, and I like to screw things down.
Yeah.
Like, you screw it down, it's gonna be there. So on this design, I went with the 3 threaded holes. So pretty much these ones are that you use to screw the burrs into the upper burr carrier. And then I also added the 3 alignment pins, so you don't have to use the shims to align the burr, to center it. So pretty much 3 pins, that's gonna, create a 3-point control.
When
you
for your
you put it in, and it's gonna be always perfectly
Wow.
centered. And then for the upper burr carrier, we're gonna screw it in from the back because you have the access to the back. But for the lower burr carrier, you can't access the bottom to screw it in. So I have designed a little clamp that I'm gonna bring. So we have a little clamp, and that clamp goes in here. Like that. It's a tight fit. It's gonna be a tight fit, yeah. So the clamp goes in, and you screw it like with the 2, 4, 5 screws, and that clamps the burr down to the burr carrier.
Yeah, because you see there's this groove here for you
Yes,
to
there
stick
is
it in. Yeah.
exactly. There's a small step, and then the interesting thing is, I know a lot of people like the things to be clean inside of the grinder, like no coffee stuck anywhere.
Yeah.
So at the same time, this clamp kind of closes the access to the underside.
Oh, so nothing can slip underneath.
Nothing can slip
grounds.
underneath.
Yeah,
Exactly.
Yeah,
So
got it.
this seals it underneath, and on the upper burr carrier also, because these are flat, that seals the bottom
Okay,
too.
no coffee can go underneath either. Okay, there you go.
So it's gonna be much cleaner inside. I mean,
Okay.
I know it doesn't matter for the end result.
But-
really,
But people care about
people
that,
care,
right? You're like, oh, I
exactly.
want my 0.0001 grams of coffee out of this, right?
Yes.
It's like, all right. Yeah, but that's the exciting reveal.
Yes.
If you watch this far in the video, you'll see it,
Yes.
right? So,
and the interesting part about these also, like with the pre-breakers removed, the actual this grind path length is about the same as 120 mil burrs.
okay.
So I don't know if that tells, if that makes it equivalent or not, but
But it's cool, right?
But it's cool.
Yeah, and then cleaner.
yes.
Yeah, more on that later. We'll do another video. There'll be another video on the burrs and
Yes.
the design and all of that, but little sneak preview in this one.
Indeed.
Okay, so we're in, this is your showroom or?
Like
kind
a
of
showroom,
cool
that's where we drink coffee when we have time.
But I brought my grinders over here. So I'm gonna put this guy down and then we can go over here. Because this is so cool to be able to see all the different generations
Let me make some
of
space.
monoliths. Yes. So here's my MC4 that has the Shurikone in it. But it's like, yeah, you can clearly see that all the different generations of monoliths in here. I brought my 5X here. This thing's been in so many videos and it's gone all over with me and it's been so reliable. And we were pulling some espresso here, but let's do a quick walkthrough of what you have here.
Yeah, well, let's go start with the first one.
Yeah, because it's so rare to, have these all in one room.
Yes, so this one was the original design that we started with, and this one is with a screw lock. First one made, I think I made, I don't know how many, not many of these. And then this worked fantastic, but people said, well, sometimes I forget to lock the adjustment and then I grind coffee and it spins out. So I didn't like that and I wanted to make it better. So then the next model was this. Doesn't have a screw lock, you just adjust it. And I also made it shorter. So now it's another, wish from people was like, it should be easier to fit under the counters in the kitchen.
And you have the portafilter hook.
Yes.
These ones were the Mazur 68 or 71?
Actually, these ones were the compact 68s.
Oh, compact, right. Okay, wow, yeah. And then you switched to Mazur.
Then I switched to the Mazur.
Yeah, okay, I see.
Because compact didn't want to sell me Burs.
Oh.
Then I switched to the Mazur.
Okay, I see. You just have a Slayer here.
And then Slayer, and I love grinders.
Yeah, you got a lot of stuff.
I will buy, we have many more grinders. And I have almost all of the single dosing grinders out there.
Wow.
And I just love seeing what people do. And then on this one, this is the test model of the first flat with a pre-breaker. So 75 millimeter burrs, the flat didn't have a pre-breaker. So the last batch of the flats we shipped, they all have a pre-breaker
Yeah.
built in. So this was the test model
Yeah.
for that.
The flat made a comeback after all
The
these years.
flat made a
Yeah.
comeback. And this one is a test model for the first conical with a dual burr. So on this one, I just took the Maser burrs and I cut them to size. So I can test, I wanted to know whether the pre-breakers will work and how will that work. And we did a lot of testing with this. I used this for about 6 months. And pretty much at home, I would make coffee in the morning for my wife and me. And I would make one on this grinder with a pre-breaker. I would make one coffee on a grinder without pre-breaker. We would taste both and we would record which one we like better. So pretty much like the testing was, what do we like better? Not like, can I taste the difference or anything? For me was like, do I like it better or not? That's the only thing that matters, really. And we did it for about 6 months, and 90% of the time we liked better the dual burr configuration. To go into the history of the dual burr, so pretty much the reason how I got onto this dual burr thing is the observation like that you can test at home. If you grind 18 grams of coffee, you dial in your grinder for espresso, say 1 to 2, you grind 18 grams, you pull a shot, flows great. But then you grind the same 18 gram dose, but you grind it bean by bean, then you see your grind is suddenly too coarse. The shot is gonna flow way too fast. So my thinking was, okay, then what's the worst case scenario that can happen really is if you have that variable flow. And you usually get that if you grind the beans and you see a lot of popcorning. So you grind the beans, you dump your 18 gram dose, but you see a lot of popcorning. So my thinking was, okay, I want to pre-break this to have a constant feed into the fine grinding burrs. And I want to have some buffer between the pre-breaker stage and a fine grinding stage so I can fill that buffer, because the pre-breaker stage grinds faster because it's just crushing the beans. So it's much faster than the fine grinding stage. So I wanted the buffer, fill up the buffer, and then the final grinding stage is much smoother. And that's pretty much the reason for the dual burr. This one is just testing some different motors, configurations. This is a standard. This is a test with a pancake burrs.
Yep.
So that's my design of the pancake burrs. Heat treat oven. It's here when we needed to heat treat like metal. This is the Max. What did I think I was testing the Twacker on this one.
Yeah. I mean, the Max has really gotten some upgrades across the last few years too. I mean, well, actually, this is an even older
That's
base,
the old, yes.
But then with the new collar
Yep.
and the
Yep.
Twacker.
Well, that's what I had on hand.
Yeah.
I had the old base, and it's a small switch too. So it's a super old base.
Yeah.
This is like one of the older models, This is just a straight up. I don't remember what this one is. I think it's a single burr. Yes, that's a single Maser burr.
Okay, so not Kafatek anymore, Maser.
Yep.
And then
This one is also like testing different motors with a variable speed before we switch to the DC motor on the conical. So this is a conical with pre-breaker, everything in there, pancake burrs. I don't remember what this
that is mine.
That's yours.
MC4.
Oh, I don't remember seeing that one.
Yeah. I had the Mazers in here, and then I swapped them to the Shurikones.
All right.
Londinium.
Yep, we've got the Londinium.
And then
So why the
Max.
switch from the vertical to the angled?
So pretty much like one of the biggest reasons is, two biggest reasons is this is easier to fit under the counters, easier to load. So like if your clearance is very tight, with this type of a grinder, it's hard to load the beans. But if you tilt it, it's much easier to load the beans if it's under the counter. And the second is like just to improve a flow of the beans out of the grinder a little bit. It's maybe it doesn't make a huge difference, but it helps a little bit.
Yeah.
Just for the gravity to take those beans down.
It also looks cooler.
It looks cooler indeed. And that was actually the original design for a flat and the max. It was always angled, the design.
Yeah, so a ton of different generations of monoliths in this room. It's just years and years of history in here, and it's just amazing to see it. This is fun. This is something that I've been starting to see more of these where people are doing very custom colors, custom runs of the Max and Conicals. The first time I saw this was some guy got a gold flat Max.
Yes.
And that was the first time I was like, oh, you can actually, and then some people in the Bay Area, local to me, they have like murdered out flat Maxes. They got like the full red anodized also set up, but you could do other colors too.
Yep.
So,
yeah, these are some experiments in the anodizing,
so cool.
and these are the powder coats for the bases.
Yeah, so
I really like this one.
yeah, I mean these are textured. It's like textured powder coat. It's so interesting to have this. Oops, shoot.
Yeah,
But-
that one is really cool.
Wow, look at that. But yeah, I guess if people want to get custom ones, they just email you.
Yeah.
Yeah. So if you guys want any custom colored ones, or things to your, how you want these designed and all of that, different colors, different anodizations.
Yeah, yeah.
Email Dennis.
Yeah.
Yeah, but it's so cool to have these colors here.
Yeah, and here's the model, like the first one. This one is from 2021. It's also the Burs without the pre-breakers and with the pancake set on the top. And this one.
Oh. Oh, this type of.
This one. So I was kind of wondering, okay, I don't remember how much. Yeah, you see, it's got like
get
a.
the slacking
Yep.
the inside. So a lot of prototyping and playing around with things, and it's just this is so cool. Different generations of Burs, but yeah, it's like everything happens here, right? All the design, all the manufacturing, the testing, everything just happens in-house, and that is just something that is, you don't see that anymore, and it's so fun for me to be able to come here. But also, I want to show this space off to you guys, right? This is when you go and you order a monolith, right? There is a process to this. There's a life cycle of that your grinder gets made, it gets tested, gets shipped out. It's all done here in Seattle, right? It's so hard to manufacture things in the United States. And also, there's something about when you use a monolith, it feels so good, right? It's like everything you touch, the different touch points, right? They all feel amazing to use. But, just wanted to show all of this off, right? What is it like? What is Kafatek, right? We're here. You can come to the shop and see, right?
Yep.
But otherwise, I really want to thank Dennis for walking us through and showing us everything here. We're gonna have some more videos, of course, but this is the one. Just wanted to show the space off. It's so cool. So thank you so much, Dennis.
Thank you.
Yeah. Okay. Yeah, you literally have a gym here.
Literally a gym. There you go.
You guys work out?
We gotta work out. Gotta stay healthy to make grinders.
Wow.
Yep.
So you only get 18 usages.
We got 18 blanks out of that edge. Fortunately, there's 4 edges, so I can at least get, a decent amount of burrs out of that.
But it's a microscope. You can see.
Yeah, it's a microscope. And so we use it for inspecting our tools. And let's get this adjusted in focus here. This is a tool that cuts the geometry in a burr. And you can see it's all chipped and ragged and sawtooth. And it's really hard to pick up, but that's not obviously going to cut well. So we use this microscope for that. Bringing in this burr. Every burr, we actually measure the exits after cutting. Scoot in as far as we go here. come over here and I calibrated this guy to tell me exactly how wide that cut is on one side to the other, about 0.7. We'll come over here to our calibration. 7 is what
Oh.
we're aiming for.
And you can't, yeah, you cannot see that at all.
There's no way I'm going to be able to measure that or see. So we use this microscope and we measure every single one. And I rotate and I just check that there's clear channels and exits. The reason why we use these is because they're force sensing. So it can tell using the fingertips when it's hit an object. And we'll use it to push it into position as well. Dennis had to program all this. Well, there you go. Okay, dropped it in the vise. Now it's going to use those fingers, sense it, and apply a certain amount of force to a stop. Just make sure it's centered and in position. So it's pretty intelligent. It knows, you know, what it's doing, where it's at, what operation versus 1 or 2, you know, taking in, putting out.
Close it up and then it begins.
And then it begins. The machine will probe and make sure it's the right size, material.
Picks the right bits.
Yep. They're about 40 minutes per, that's half of a part.
Mm-hmm.
So the other half's about 20. So it's about an hour to get one of those made. So over the course of the day, I'm really only getting, you know, 8 of those. One part for one grinder, 8 of them a day, coupled with the part carrier, the same amount, 7 or 8 a day. That's about the limit. Off the run.
Yeah. Wow. This is so cool.
Yeah, that way I can, you know, I can be doing other things. You know, like this one's done, ready to come out. You know? Check that. Make sure that spins. And then grab another one. Clamp it. Ready to go. And this will run through 3 or 4 operations before it'll stop. And I'll have to check the shaft for the bearing is the right diameter. And if it's not right diameter based off of heat and wear on the tool, I'll have to adjust some parameters to get it back into dimension. Every single part. Which is again why we can only do so many a day.
Yeah, low volume.
Low volume, but like every single part goes through hands and tools to make sure that they're all how they're supposed to be. Because then all the tolerances stack at the end of the day when the grinder is fully built. And you want everything to be as low as possible so your overall is within our 10 microns.
Yeah, wow. But yeah, it's like a bit of human touch, bit of automation, but very precise.
Yeah. Well, and we hand wash everything, we hand dry everything, we hand deburr everything. Like, and there's only, you know, 4.5, 5 of us total doing, you know, all of this. It's a lot of hands-on work, for sure.
There it's going.
Ready to go. So it's going to cut that size diameter down to this size. And just all that material gone, and then those green bins are the recycling bins. But yeah.